I have no idea how well this is going to record because I'm going to have to kind of like turn away from the microphone for this session. But today I'm going to do a session about shaders, and in particular, I'm going to show you how to use Shader Graph. So shaders are basically programs that you run on your GPU, and they're used to make graphics happen, basically. And Shader Graph is a nice kind of visual editor for shaders. So traditionally, you'd use code to write shaders, but we're not going to do that. We're going to use a nice kind of visual kind of environment. The first thing I'm going to do is I'm going to make a new project for this because there's some requirements to use Shader Graph in Unity which are kind of annoying, but I'll explain why while my project is creating. So you'll want to follow along with this as well. I'm going to go New, and it should select your most recent Unity version, and I'm going to select this button here that says Universal Render Pipeline, and I will explain what this is while it's making the project. So I'll give it a project name like Shader Graph Tutorial. It'd be great if I could capitalize the S. And I'll go ahead and create. So that's going to take a little bit of a while to open up the project and kind of copy over the template. And then at the time, I'll explain why we're using this different template from before. So you saw that I think there were 4 templates there. One of them was 3D, one of them was 2D, and then there were 2 others that I hadn't talked about before. Prior to about 2017, Unity had one kind of set of rendering code, and all rendering in Unity kind of was fed through this pipeline, as we call it. And that's great. That meant that Unity was quite easy to pick up. You only have to kind of think about one set of kind of rendering code. The renderer is the code that basically takes all of the meshes and the sprites and stuff and kind of displays pictures on the screen, basically. But the problem with the renderer is it was kind of opaque. So the renderer code, you couldn't just dig into Unity and have a look at it, because parts of Unity, part of the Unity engine, are kind of hidden from us as users. So starting in, I think it was either in 2017 or 2018, they released this system called Scriptable render pipelines, and the idea behind these is that as a programmer, you can make your own rendering pipelines. You can control what rendering codes to use in Unity. And the idea behind this is if there's a bit that you don't need, then you don't have to write code for it. And that kind of ends up more efficient. For example, if you wanted to only target certain platforms, so if you were making a game and you were only going to have high-end desktop PCs as your target, you can write a pipeline that only considers high-end PCs and ignore everything else. Or if you wanted to only make a VR game, you would write rendering code that only works with VR and ignore every other platform. So it's more efficient. The problem here, of course, is that one of the reasons that people choose Unity in the first place is you don't need to worry about all of that code. So they prepared 2 template scriptable render pipelines for us. One of them is called the Hdr render pipeline, and that's designed for high-end PCs, consoles, and VR projects. And the universal render pipeline, which is the button that we clicked, which is meant for everything. So mobile, low-end PCs, but it can also target consoles and VR and everything. Universal just runs on basically everything, or it will run on everything. And I tell you this because some of the new features in Unity are exclusive to the new render pipelines. One of those is Shader Graph. So we're going to have to click this different button and things work a little bit differently with the rendering stuff in Unity, but it means we can use Shader Graph, which is what we want to do today. So has everyone's project kind of loaded up in the pod? I was hoping that in the kind of time it took me to explain all that they'd all loaded up by then. Evidently my computer's a little bit faster. That's fine. We can kind of go into a little bit of the theory stuff and kind of stall for time while your stuff is kind of still opening the project. It's kind of just raise your hand when yours is installed, and when all of you have got your Unity project open, I'll actually show you how to use Shader Graph properly. I think, okay, I am going to create my first Shader Graph, but I'll go back and tell you again once all yours is opened. So you right click and you go to Create, Shader, and there's a bunch of options. So all these options here will create a shader code file, and we're not interested in those today. Code is icky. Instead, you can select either a blank shader graph, a subgraph, which we'll get onto those. A subgraph is basically a way to encapsulate some shader graph nodes into kind of like one file, and then you can just reuse all of them by just importing the subgraph, and it will just add like one node onto your main graph that kind of encapsulates the bunch of nodes. So it keeps your graphs cleaner. And we are also interested in the universal render pipeline dropdown. If you were using HD render pipeline, it would have a different dropdown here, and you'd have different options for graphs. These are graphs that are basically set up to automatically work with universal render pipeline. So we're going to use one of these. And our options are a lit shader graph. So a lit shader graph will automatically apply Unity's lighting systems to it. The sprite lit is similar, but that's for 2D sprites. So lit is basically if you're going to have like a 3D object, and the sprite lit shader is if you're going to have a 2D object. And then the unlit versions of those are it's going to apply none of Unity's lighting automatically. So if you have an object where if you have a light next to it, you don't want it to be kind of like shadowed on the other end of the light, you'll use the unlit graph. And that's actually what I'm going to use first. So I'm going to click unlit shader graph, and like anything else in Unity, it will just create a new asset down at the bottom of the project view. I'm going to call it test graph. Doesn't really matter what you call it. Obviously, you'd give it a more descriptive name if you're making a real effect, but this is just a show. And I'm going to double click to open it. And you get this window opens, and there's a lot going on here. I'm actually going to take this window out and then maximize it so we can get a much better look at what's going on. How well can you see that projector actually? I don't know if there's a way to make that brighter. Can you see that okay? Yeah, I'll try and stall a little bit so that when I start adding nodes to the graph, then we'll actually have this open and be able to follow along. I was wondering if this projector, because some of the words I'm finding it hard to read them at this distance, and I'm right next to it. I'll just explain some stuff, and hopefully you'll be able to follow around kind of vaguely. So if I zoom in, then we kind of have this strange thing in the middle, and we have a couple of windows at the right and the left. And these are all things that we can kind of modify. So stop, right? How about you two? Is that good for you? Almost. Okay. That's fine. So there's a lot of buttons here, and they all do something different. So in the top right, we have the graph inspector, and if I get it right, I can expand it slightly. So the graph inspector is similar to the Unity editor inspector. So if you click on something, it will tell you properties about that thing. So if I were to click on a node in my graph, there's actually two tabs here. In the node settings, so if I very quickly just add something just to test it, let's add a color. So that's actually a terrible idea because that has only one setting, but that's fine. So if I click on a node in my graph, in the node settings window, it's going to give me some kind of extra options to develop with that node. And some nodes have more options than others. There's just two tabs here, so you click the node settings. The graph settings, on the other hand, will give me kind of macroscopic kind of options to do with the whole graph. So because we picked the unlit shader graph template, the material type that is giving me here is unlit, as I expected, and I can just change that here. So if you created the wrong kind of graph and you wanted to go back and change the kind of graph that you're using, there's this drop down here. So I can just change it to lit right here. And in fact, if I do that, it's gonna add a few settings down here, but I'll get onto those in a second. I'm going to change that back to unlit for now. I can also change the type of surface. So if I wanted my object to be opaque, so not see-through, then that's fantastic. If I change it to transparent, then I'm able to change how transparent it is using the alpha option. So there's just a couple of options there. I'm going to stick with opaque for now. Just going to delete that. And I'll talk about the stuff in the middle. So we kind of have these two sort of blocks that exist here. And one of them is labeled Vertex, and one of them is labeled Fragment. So Vertex, all of the options in here, and these are outputs from the graph. So basically, I will take nodes, and I will be kind of funneling some things into these things here. If I don't edit them, then there's some default values here, and that's great. So these three are the vertex options. And the vertex stage, or sometimes it's called the vertex shader, but that's a little bit more confusing, I guess. The vertex stage is for modifying the positions of vertices on your mesh, on your model. So if I had this table and I wanted to kind of move the position of this table inside my shader for whatever reason, maybe I have an effect where I want to make it like wobble around or something, then I can do that by modifying the position on the vertex stage here. So it'll take the vertices would be like corners here, corners. I could add an offset to them, and I would add that into the position. The normal and the tangent are basically directions that are used usually for lighting. So a normal vector is one that kind of points from the surface, kind of points upwards out of it. Normally. Usually, sorry. But we can change that. So if we wanted, for whatever reason, change the normal from pointing out here to pointing to the side, then we can do that very well. And for an unlit graph, that probably won't do much. But for a lit graph, that would edit quite a liking it. And tangent is similar, but a tangent vector is one that points kind of perpendicular to the surface. So if my normal is like this, and my tangent is like across the table on the surface. And we modify all of this. The fragment stage is what happens to the color, basically, of all the pixels. So between the vertex and fragment stages, kind of behind the scenes, Unity will take the object and its vertices, and it's going to kind of slice up all of the parts of it into pixels. Fragment is a technical term. Fragments usually correspond to a pixel, but in kind of like lower down shader terminology, a fragment is one of the elements that I can change the color of. And it's called fragment rather than pixel here because technically sometimes we can have fragments that are either larger than or smaller than a pixel, but it usually corresponds 1 pixels. So think of fragment as just what kind of properties each pixel of my object has. And the only option that we have on an unlit opaque graph is base color, because that's the color that will be output by this object. How's your thing uploaded? Great, started in notes. So that's just a very brief overview of what all these stages are doing. Is that kind of clear, or any questions so far? Fantastic. So, we've got these options and we want to do something. There's kind of multiple ways of doing this. If we wanted to edit the color, then we have the base color down here. I can left click that like anything else in Unity. And there's also this default that's kind of already plugged into it. So I can change this. If I click on that little gray box, then it will bring up a color picker like anything else in Unity that has a color picker. And I can just change this to red. And then down here in the corner, you hopefully have a moving preview. I can make this bigger. And that's going to give me a preview of what this object will look like, or what this shader will look like when applied to a sphere. So that's great. We can change the color like that. We can also, if we so wished, use a color node. So anywhere on the graph surface, if I right click and go to create node, which is the top option, then it's going to bring up this dialog window, and this will list every different node that Unity can or what shader graph can use. So a node is like a chunk of behavior, or it can be, here is a type, here is some data, I don't need to do something with it. So in this case, I'm going to type in the word color, the American spelling of color, because most programming uses it without the U, which is kind of annoying. So if I just type in color, it's going to bring up a bunch of options that have the word color in it, but I just want the one that is called color. So I need to scroll down a bit, and it's under input basic color. And as you saw before very briefly, I added this node, but it's added it again. And this is similar to what we just did down here with the base color, with this kind of like color picker. But I have it in a node now, and I have this much bigger color picker little window. So I can do the same thing. I can make this red, and I can bump up the alpha a bit. And that's all good. You'll notice that on the right-hand side of the node, we have this little circle here, and it says out next to it. So I left-click drag from that and drag it onto base color. Then it's outputting from that node, and it's inputting it into the base color little output of my graph. So this is basically what shader graph is. It's a way of kind of adding behavior and adding types and stuff to this kind of visual surface, and using these visual elements to kind of add things together, multiply them, that kind of stuff, as we'll see kind of later. Is that all clear so far? Is that all good? There's other ways to add colors. So currently, if I were to use this shader and apply it to a material in my Unity inspector, or back in the Unity editor, there's no way to kind of change this color from the outside. So one of the kind of advantages of Unity, and we saw this with scripting before. If I write a piece of code and I have some variables at the top of my script, then I was able to modify those back in Unity in the editor. So I didn't have to keep going back into the code and changing it. And there's a similar way of doing that here with shaders, and we use properties for that. So in this top left window, this is a list of properties. And yeah, a property is just like a variable that is input to this shader graph. So if I click the plus button, it's just in the top right corner of the properties little window, then I can add loads of different kinds of properties. And some of them you'll probably never use, and some of them are going to be used quite a lot. The ones I use the most are probably color, texture 2D, and either float or vector 2, that kind of stuff. There's some types that are a lot more common. But for now, I'm going to pick color. And it will add it to this tiny little list, which I hope you can kind of see that in the top left corner. And this is the name of the property. So right here, we're going to have a kind of a human readable name. So this is something that I would want to recognize as a person rather than the computer interpreting it as a name. Because there are ways of giving these properties kind of under the hood names that the computer will use behind the scenes, but that's kind of a little bit kind of later on. I'm just going to call this base color. So I just type that like a normal human being rather than being all programmy and having like camel paste or whatever. I'm just going to call it base color. Ooh. And if I were to click on this, whereas before when I clicked on something and the graph inspector didn't really have much, I have a lot more options now. So if I've left-clicked the base color on the properties window, and then on the graph inspector, if I've selected node settings, so there's two tabs there, graph settings and node settings, then I get some options for this property. We see the name, which is the one we just typed in. We see this reference, which is the kind of the computer readable name, like I mentioned before. We don't need to change that. That's important if you're using scripting. So in scripting, there are ways of kind of referencing a material and changing the properties from the scripting side. So that's useful if you wanted to change a color at runtime. So I would reference my material, I'd kind of find the name of this property, and I could input my own colors from the scripting side. So while the game's running, I can change the colors like that. We can change the defaults, which is probably the most important thing here. So, you know, I can change this to whatever I want. I'll just make it red again. Actually, I'm going to make it different. I'll make it yellow this time. So that means that, you know, when you create a new material and you attach this shader to it, And we'll get on to materials in a second because I realised I didn't actually explain those. It will have this property will be yellow to begin with. But we can change this from outside this shader, so that's great. The mode and the precision are stuff that we can get into later. They're not that important right yet. But we have our property now, and we might want to use this. So to use a property, there's two ways of doing it. Well, there's probably more than two ways of doing it, but there's two main ways of doing it. Either I can just left-click drag the property itself onto the graph. And that's going to give you this really tiny little node here, which just gets the property value. Or we can right-click and create node, and there is a properties little option here. So this drop-down called properties will have every single property that you've added to your graph, and you can add those that way. As you'll see, if I click that, it's the same thing. But we only need one. And just like before, I can take the output of that and drag it onto the output, and then my preview will say it's turned yellow now. So it's using the value that I had in the property. So it's yellow now. And I can get rid of this node. I can just left click, select a node, and then press the delete key to get rid of it. Any questions so far about properties and adding playing with the values? Good. So, we've got a very basic shader graph now. This shader graph, the only thing it's going to do is kind of give us the option to change the base color of an object. So that's the starting point. If you've ever done programming before, then maybe the first program that you wrote for any given language is like the Hello World program. You can't do that for shaders because that would be very complicated to just display the word Hello World across an object. This is probably the Hello World program of shader graph, so this is your first shader. Well done. Well, maybe it isn't your first shader, but this is this first shader. This is your first shader graph, probably. Now I want to use this somewhere. So, first thing I'll do, in the top left corner, there is a Save Asset button. That's going to be very important to click that. I think you can also click Control S and it does the same thing, but make sure you save your shader here, because if you try using it in Unity and you haven't saved it, you might be kind of wondering why your changes haven't come through. I do that a lot. I'm going to minimize this window a bit. I'm going to move it out of the way. And then back in the scene view, I want to use that shader now. So the way I do that, if I just kind of zoom in the graph, zoom in the scene. The nice thing about using URP as a template is that it kind of adds this scene for us, so that's kind of nice to just kind of see how things work. There are some things later on that I'll kind of talk about that are nicer in this little test scene, because they've set up some stuff for us that is going to kind of help later. But for now, I'm just going to add a sphere, and I'm going to add our shader to it. So, first of all, I just go to Game Object, 3D Object, Sphere. That's going to add a sphere for me to test with. I can place that wherever I want. I'm just going to place that kind of vaguely in the middle of the scene somewhere. Kind of there-ish. So it's going to be our test object. When I'm making shaders, quite often I like to just have a test object in the scene so I can test it out as I'm going. And now we're going to want to create a material to add to this object. So a material is kind of what it sounds like. It's just something you attach to objects to make them look like something. And Unity kind of gives us some materials to start off with. So in this project, this template, there's a few materials already. But we're going to make our own. So if I right-click anywhere in the project view, and I go to Create Material, it's kind of in the middle of this gigantic drop-down. So Create Material. I hope you can find that okay. It's kind of hidden in the middle. And I'm going to call this whatever I want again. I'm just going to call it, let's call it Test. Let's call it Test. So I've got a brand new material. And in the to create the material.
Yeah, I just missed that.
Yep. So in the project window, so down at the bottom here, you just right click and then you go create right at the top. And then material is kind of somewhere in the middle.
Oh yeah, I got it.
Yep. Fantastic. So if I've left clicked my new material that I've just added there, this is going to be using the Unity kind of the default material to start off with. So the Distort Shader is quite nice. It has a lot of options for a realistic material. So it will use the lit version, and this is going to automatically apply lighting. So you'll see this sphere is kind of like, it's nicely lit because there's a directional light over here and it's pointing kind of in this direction. So we've got a specular highlight on the object, which is quite nice, and it's got some shading in the back. But obviously, if we don't want that, we don't want to use our material that we just made, or shader that we just made. Sorry. So at the top of the kind of the inspector for the material, there is a drop down. It's labeled shader. It's right at the top, and I'm going to click that, and that's going to allow us to change the shade of the material is using. So if we want to find the one that we just made, there is a drop down called shader graphs, and by default, Unity will put all the shaders that you make with shader graph in this little drop down. So go to the top here, just left click the little drop down and go to shader graphs, click that, and we'll see a bunch that are already made for us, but then there's ours at the bottom and it's called test graph, or whatever you named it in. So I'm going to click that. And now the little preview down at the bottom for this material is kind of turned yellow because that's what our shader looked like. And then I can left click drag from here onto this test sphere, and it's going to turn yellow. Like I mentioned, one of the kind of the powerful things about properties in shaders especially is that I can change the properties right here in Unity. So without having to go back into the shader, I can change this property, and I can have multiple materials. So if I duplicate this, if I select it and press Ctrl D, it will duplicate. And I got another material here that's kind of using the same shader. It's exactly the same so far. But I can change the base color, so I can make this kind of pinky, kind of a pinky color. And now I have two materials that use the same shader, but they've got different properties. So this is kind of one way of, I guess, minimizing the amount of effort that you put in, or the amount of work that you have to do to have a range of materials. You don't have to write a bespoke shader for everything. You can write one shader that does kind of a bunch of stuff, and then apply different data, and it will look completely different. So as before, I can just drag that on there, and it's pink now. Is that all clear? No questions so far? I'm just going to open my shader graph back up. Because the windowing system is kind of a bit finicky in Unity. I'm going to maximize. So we're back on our graph. Obviously, shader graph isn't going to be very interesting if all we can do is change the color of something. So we're going to have to add more nodes to this. Probably one of the things you'll do most of the time in shader graph is work with textures. So a texture is basically just an image that you can apply to something. So yeah, texture is kind of a computer graphics-y term. It just means an image. So we'll usually take an image that has red, green, blue, and alpha channels on it. So the red, green, and blue, of course, will be those colors, and the alpha channel will be the amount of transparency in the image. So if you go into any of your kind of popular graphics editing programs and export any PNG file, most of them will have those 4 channels on them, and we'll be able to work with those. So the first thing I'm going to do is I'm going to make another property, and I'm going to make a texture 2D property this time. So yeah, it's the plus arrow here, and I'm going to select texture 2D. And I can again name this what I want. I'm going to call this base texture, I think. But we could have named that anything we want. So this is going to let us do the same thing we did with the base color. It's going to let us apply texture back in Unity and change it whenever we want. So I'm going to drag that onto the graph, and that's going to give us our texture. Now, you'd be tempted to think that we can just kind of like drag this into base color and it's just going to work, but unfortunately, if I do that, it won't. So I can't just connect this straight away to the base color. I need to do something first. So textures are a little bit more technical than just colors, so I need to get the data from the texture. And the way we do that is there is another node called Sample Texture 2D. So I can drag out from this node, from this pen here, and it will bring up the same dialog as before to create a node, but this is restricted to only the nodes that accept this as an input. So that's quite useful if you're kind of not sure what nodes you can kind of do from any one position. If you just drag out from, for example, this texture 2D here, it's only giving me the nodes that accept the texture 2D as an input. And I'm going to call sample texture 2D. And there's a couple of options, but just select the one that's only called sample texture 2D. There's another one called LOD as well, but we won't worry about that for now. So I'm going to click that. It's going to bring up this very, very big node. And there's a lot of inputs and outputs here. So we've of course got our texture that we've just kind of input. But we've also got two other inputs called, one of them is called UV, and one of them is called sampler. Yeah, so it's called sampler. And there's a couple of options at the bottom, and there's a lot more going on with this thing. So just to kind of very briefly go over what they all are, the UV is the texture coordinate. So the way that kind of sampling textures works. So sampling is the process of going into the texture's kind of data and picking the correct pixel to apply to my object. And the way that it works is that if I have, again, if I take my table as an example, there's basically a coordinate system. There's kind of a mapping from the texture, which is a flat 2D kind of array of data, to this kind of 3D object that has kind of different, it's not a square, it's not just a rectangle. So I kind of have some way of mapping which pixels in this texture apply to which parts of this model. And these are called texture coordinates, or UVs for short. And you have to worry about UVs if you're doing modeling in a modeling program. But just to kind of very briefly kind of mention them, a UV is just this mapping. So Unity will kind of apply the UV coordinates from the mesh as they are. So this is something that you don't necessarily always have to worry about. So if we just use the sample texture 2D node like this, then we're not going to have to worry about supplying our own UVs. Unity's doing it for us. But I just wanted to briefly mention what UVs are, because you might not have come across them before. And the sampler, this is actually a sampler state, which is accepting. That's the type. Sampler state is kind of a bunch of options for sampling. Again, the default is going to be okay here. If you don't put anything here, if you don't change it, it's going to use the import settings that you had on your texture when you imported it into Unity. But that is something that we can manually override here if we want. So those are the inputs. Down at the bottom, there's a couple of options. The first one is the type, and it's either default or normal. Default is just going to read all of the values from the texture as colors. It's going to go, okay, this pixel is red, this is a red pixel. But there's also a process called normal mapping. So normal mapping, kind of briefly explain this one as well. If you have this surface, say if it was kind of really rugged and stuff like that, so it wasn't a flat table, if this had like loads of bumps and crevices and scratches and stuff. If I wanted to model that into the geometry of this object, then I'm going to need a lot of vertices on my model. And that's really inefficient. The reason I want to do that is because I would want kind of the lighting of my object to look right, and I want the shape to look really, really good. So there's an optimization that people invented years ago, where you would model the table exactly as it is currently. You just have like a flat surface with no bumps and crevices on it, and you render a texture that defines where the bumps and crevices are. So I could probably actually find a normal map. It would be easier to show you that. I think there are some in the example assets for this project. If I just find them briefly. Wood might have a good one. Okay, there are a couple here, but they're kind of not very good for showing you what I want to show you. Is that not normal? That one's probably the best one that's here. So I think this is apparently a plastic a kind of a, don't know what pattern you call this, kind of like this, like lines of plastic. So this is like a bumpy plastic texture, normal. And make this a little bit bigger. So if I wanted my table to kind of look flat, then my normal texture would just be this kind of just blue, which means that there's like no bump whatsoever. But what they've done here is they've modified the colors such that these little bits are meant to be raised up, and these bits in the intermediate are meant to be kind of like lowered down. So these normals that we can decode using the sample texture 3D node are used for lighting. That's not something we're interested in right now because we're using an unlit graph, but later on we might want to use normal mapping. So this is just a way of kind of faking all of the lighting calculations that you would have on a really like rugged or kind of shaped object, but you only have simple geometry like a flat circle. So I'm just gonna kind of open my graph back up again. We're gonna keep this as default because we just want color. And we also have the space down here. I have a tangent or object, and honestly, I usually just keep it as tangent. That's not something you'll have to worry about in most cases, so I'm just going to leave that as tangent. And then we get to the outputs, and it looks like there's a lot, but these are actually mostly the same output. So the top output is RGBA, which stands for red, green, blue, alpha. And that's just like I described before. It's going to take the pixel at the right UV coordinate and it's going to say what color is it. It's going to output that. If you pick the type as normal, then this data would be basically a direction that is kind of decoded from the normal texture, and it's kind of like, it would kind of translate it into a direction that it would use for lighting later on, but we won't worry about that. The other outputs, the other four outputs are R, G, B, and A. So if you wanted to output the entire color, you can use the RGBA output. If you wanted to just use one of the individual channels, so if I just wanted the red, I just wanted the blue, I just wanted the green, or I just wanted the alpha, I can use those four individual pins that we have there. And there's another way to do that. If it didn't have these pins, then there is a way of taking kind of a vector. So a vector is the type that we have, or it's multiple numbers. The RGBA output is a vector 4, it's a 4-element vector. I can actually just output that. I can use a node called split. And that does a similar thing as this node is already doing for us. So it takes my 4-element vector and it splits it into its individual 4 numbers. That's something we don't have to do because it's given us those 4 values for us on this node. But that won't happen with every node, so that's something you might have to do quite often. Move this a little bit closer. So you can multi-select nodes if you kind of just left-click, drag around them. It'll select everything that your box goes over, basically. So just like before, now I have a 4-element output. That's the same thing as a color, so I can output that to the base color output for my graph now. So if I do that, it's going to turn white because I haven't actually attached the texture to this property by default, so it just uses a completely white texture. But now you can see that my main preview has kind of turned white. And I could go back into Unity and then show you how to attach texture and use a property like that, but you can kind of guess how that would work, so I'm going to go on to a little bit more stuff we can do with the graph first. This is all good and everything, but again, we're just taking a property and we're outputting it directly into the base color output, which is nice, but we can do more interesting things with the graph. So quite commonly, you'll have both a base color and a base texture. And kind of, well, it's just a common thing to do with materials is you might want to have your base texture. So say, for example, actually in this room is a good example, you'll see that we have the same type of chair, but this one's green and this one's grey. What's quite common is that you will have the texture could be grayscale, so it looks like this. So we have like a tint color that we apply to make this one green. That's very easy to do with colors. We can just multiply them both together. So the way that multiplying colors works is quite nice. It just takes kind of, if we did it here, it would take the red component of our sample texture 3D and the red component of our base color, it would multiply them together. And then it would take the green and multiply those together and so on and so forth. kind of under the hood at this kind of point in time, each color is represented as a number between 0 and 1, with 0 being there's none of that color, and 1 means there's all of that color. So currently the output of the sample texture 2D is in fact, I think it's 1, 1, 1, 1, because we've got the maximum amount of red, maximum green, maximum blue, and it just appears as white. But we might want to multiply these together to kind of have this tint color that we can apply just to the texture. So that's easy to do. If I just kind of move this out of the way a little bit. Rather than outputting this straight away, I'm going to drag out and I'm going to use a multiply node. So it's going to bring up two options here. It's going to bring up, so if I type in multiply, it will bring up one that says multiply A and one that says multiply B. In this context, it doesn't matter which one you pick. This just determines which of the two input pins it's going to put this output into. So if I click multiply A, it's going to, just move these out of the way so we have some space. It's going to output kind of this into the A slot, and then we can take the output of our base color property and output that into the B slot or multiply. And let's multiply my colors together. And just like before, I can take the output of that and output that to base color, and it's given us a base texture that we can turn. That's quite nice. Are there any questions so far? Are we going too fast or slow, or no? Yeah, that's just some of the stuff we can do with Shader Graph. If I save my graph again, so save all the time, I'm going to minimize. I'm going to just dock this window, go back to my scene view, and then you'll see on my materials, it's really huge because I dragged that up before. We now have the option to add both a base color and a base texture in my inspector. So it's still yellow, but it's using the default texture, which is just white. You see this kind of like this little box next to base texture. In the bottom right corner, there's a button that says select. So right in the corner there, I can just press select. It's quite hard to see, but on this little box, it says in the bottom right corner, it's a little button to select. So if I press that, that's going to load up every texture that's in my project. And because we're using the URP base project, it's already got a few textures ready for us to use. And I'm going to pick one at random. Let's choose this one. If I drag that onto my object. So you can see how it's kind of applying this random texture that I pulled out of the project. And it's kind of mapping it off this sphere. It's not a perfect mapping, because if you're trying to map a 2D kind of image to a 3D sphere, there's some nice mappings to do that, but Unity hasn't picked that one for the sphere for whatever reason. You'll see that at the top of the texture, it kind of distorts a little bit, but we've got what we wanted. So as I mentioned, we have a tint color. If I just kind of like scroll around the hue of this color, some of it might look a bit weird because the texture itself has some color, but this is going to let us kind of play with the tint of the object. That's quite nice. So back on to the graph. So far we're just using an unlit material, so we only have the base color output, and that's nice, that gives us something to work with, but there are other outputs that Unity can handle, and as I mentioned before, these are all going to use Unity's lighting system. So I'm actually going to change the type of this graph. If I go to the graph inspector and pick graph settings, this is the window I was kind of talking about right at the start, I can select the material drop down and pick lit instead. So if I do that, this is the material, lit. Lit should be the top option. It should add kind of a bunch of options for us, so I'll just move that out a little bit. So these are all options, or at least the ones they've added, are options that are related to Unity's lighting system. So the smoothness, the normal, the emission, ambient occlusion, and metallic. And Some of these are a little bit harder to explain, but smoothness is kind of what it sounds like. It's how smooth your object is. If you can imagine like a polished kind of sphere, then it'd be very, very. You'd think of it as shiny, but if you had a completely kind of rough object, then it will look kind of sort of like this. So you don't have any kind of like highlights of light on this chair or anything. It's just kind of very matte looking. But something that's like I don't really have anything that shiny to kind of show you. I guess I'd say that this plastic is a bit more shiny because if I kind of move it around, I can see kind of like light highlights that are coming off it. This kind of ridge here is a little bit shiny. The normal is how I described before. This is the lighting calculation. So if I kind of rotate this normal, then the lighting is going to change a little bit. The emission's done. We'll kind of get onto that in a second. Ambient occlusion is another trick that we use in kind of graphics programming. So kind of a little bit difficult to explain, but if you have objects that are kind of like near each other, so for example, it's a little bit hard to see from where you are, but kind of like the edge of this table intersecting with this wall, there's some kind of like shadowing that kind of appears kind of like around the edge of the objects. So you'll see this in real life, kind of like as you get to the kind of extreme of like one object touching another, sometimes you'll see kind of shadows that are sort of around it. And it's quite difficult to kind of compute that automatically using lighting systems in kind of Unity and stuff, but this ambient occlusion lets us kind of modify that ourselves. So the ambient occlusion is basically, I think it's one if this object is kind of not occluded by anything. So occluded means it's kind of blocked off and it will have shadow on it. And if I put that as 0, then I believe the way it works is it will apply kind of some shadowing to the object. But we won't worry about that for most use cases. And then the last option here is metallic, and that one's obviously, you know what metal is. This one's easy to understand. So, got the chair again. This is not metallic. This is metallic. So metallic is also going to edit the kind of like the lighting of the object. So all of these options to do with just how much lighting is applied. The more metallic my object is, kind of the specular highlights, so the very, very shiny highlights, if I kind of look at this at the right angle, are going to look a little bit different to how they would if this is a non-metallic object. Even if the objects are both smooth. And these are really nice because rather than having to kind of like calculate how much light there is by hand using like lighting calculations, Unity is doing that for us. So it's kind of like relay it back to before. So this is physically based rendering, and it's called physically based because it's based on the physical properties of an object. Kind of before we had physically based rendering, we would kind of describe the amount of specular lighting on the object and the amount of diffuse lighting on an object. Where diffuse means like basically what you think of as how lit or unlit something is, and the specular highlights are how like really shiny bits of lighting on something. And we would describe object properties based on those types of lighting and adding them together. But as a human readable thing, it's a lot easier to just say, oh, this is 90% metal, or this is 40% smooth on this kind of arbitrary scale of the most smooth to the least smooth. It's a lot more kind of, this is how people think about objects. And then it does the calculations behind these. Any questions about that or anything so far? That's a little bit explaining, sorry. Shaders are probably the thing in Unity I know the most about, so I'm probably just going to kind of talk at you about them. Very sorry about that. But yeah, we can modify all these properties. So first thing to note is that our main preview, and it's hard to see from where you're sat, but you'll see it on your own screens, is that our main preview now has lighting applied to it. So if I change the base color to something where you can see it's probably a little bit better, something dark like that, maybe even from here you can see there's a nice kind of like highlight. That's all great. So obviously these settings are working. I should have just showed you what they look like rather than explain them all. If I put the smoothness up to 1, you'll see that it looks really polished now. The specular highlight, so this is the highlight to do with like the direct reflection from a point, from a source of light to my eyeballs. It's really tiny now. and it just kind of looks smoother, as you'd expect. And if I put this at 0, there's kind of no highlights whatsoever. It's just literal sunlit. I'm going to leave that as 0.5 because it's a nice kind of mid-ground. The normal is something we can kind of see later, and the emission is something I will go on later. Ambient occlusion we'll ignore, and the metallic. So if I put the metallic as 1, the lighting looks different. The highlights are still kind of the same size, and all that kind of stuff is still in the same place and the same size, but it kind of, the colouring looks different. So that's what it would look like if it's a metal. I'm going to leave this as a non-metal. So most objects, the metallic you'd probably have as a very high value or very low value. There's very few objects that are 50% metal, 50% non-metal. I think the thing that I'm going to go on to next is the emission. So emissive light is basically, so we have these kind of strips of light here. But obviously, they're not just lighting themselves. Like, if I looked at a bright light, I wouldn't just see the colour of the light within the light bulb itself. I would see light kind of bleeding out. That's because it's emitting light rather than just kind of having light bounced off it from another light source. One kind of thing to be aware of if you're using emissive light is that Unity won't do the light bleeding automatically. There are things that you need to kind of add to your scene to make that happen, and I will show you kind of later how to do that. But for now, I'm just going to kind of play with some emissive light. So if I add another property, and I'm going to call this, I'm going to add another color, and I'm going to call this Emission Color. Colors work a little bit differently when we're talking about emissive light. So before I mentioned that colors are basically a number from 0 to 1, but that doesn't always have to be the case. We could have a color where like the red is 5 or something like that. And those are called HDR colors. That stands for high dynamic range. And this basically means we want a color that's brighter than most colors. So for most objects in Unity, the color is going to range from 0 to 1 in each of the red, green, and blue. But if we wanted to drive our color values higher than that, there's kind of a mode that we have to add to our color. So below the default kind of color drop down, there is the mode drop down. If I click that and select HDR, not much will change kind of so far, but if we click the color picker, we have another option. So we have the same kind of color wheel as before. We have the alpha, the red, green, and blue kind of sliders. But we also have this intensity option. And if you keep the intensity at 0, it's going to work exactly the same as colors did before. But if I kind of just give this let's make it kind of pink. Let's add the alpha to 0 to 1. Sorry. That's all good and everything, but it's not an HDR color yet. If I increase the intensity though, so I've increased this to something like 2. Now it's going to act kind of emissive. It's going to have more intensity, I guess. So yeah, if my intensity is 2, it's going to act brighter than it would have otherwise. I'm going to close that dialog down, and I'm going to take my emission color, and drag it onto my graph, and then I'm going to output that to the emission. I think it's me calculating what it should look like. There we go. So it's kind of drowned out the base color. One kind of thing to kind of remember is that the base color is still working the same way. So the way that the object will look now is going to be a combination of the base color, which is like the physical, this is white. It's going to be a combination of that and the emission color. So, say like a bright light bulb or something like that. The actual base color might be white, but if it's emitting yellow light, then its actual color as it kind of appears to humans is going to look kind of yellow. So the actual physical color is going to be a combination of both those colors. So if I were to save my graph now, and just kind of close this off, Block it somewhere else. Now we've got a kind of a glowing sphere. So it might be easier to see on your computer rather than on here, but that is indeed kind of emitting light outside of itself. Now I did just mention that Unity doesn't do that automatically, but I also mentioned earlier that it's nice some of the things that the template does for us. So to make the glowing happen, you need a blue post-processing filter on your scene somewhere. And Unity does that for us with this default scene, but typically it won't always kind of add that for you. So it's just something that you're willing to add yourself. And that is on this post-process volume that is present on this default scene. So it's one of the kind of game objects kind of on this hierarchy view here. It's something that's already in the scene for us just on the template. It's called post-process volume. And it's added 3 post-process filters. There's this volume component, and there's these 3 filters here. One of them is called tone mapping, and tone mapping is a filter that kind of takes the colors of the scene and it maps them to something else. So tone mapping is something that you might see to make the colors look nicer. And it's also used when you're using HDR colors just generally to map your colors from these like very bright values that can't be displayed by my screen to something that can be displayed by my screen. So say if we had a color that had like a value of 3 on the red, we'll need some kind of mapping to kind of take it from something that's too bright for my screen to map it onto some nice values to actually display my screen. That's what tone mapping does. The second one is bloom, and bloom is the one that's making the glow happen. So if you remember nothing else from this bit of the session, just remember that you need a bloom filter to actually make the glowing happen around these objects. So what the bloom does, 2 of the options are kind of ticked here. It's got a threshold and an intensity. So the threshold is saying any color that's above that value, I want these to glow. And the intensity is how much it glows. So just on this post-processing filter, I can change the intensity to something like 5. And it's going to make my object glow a lot more. But it's still making only objects that have an intensity above 1 glow. So an intensity above a color value above 1. So anything where my emission was kind of the intensity was above 0. If I were to be ridiculous and put this to something like 0.5 and kind of put the intensity back to 1, then you might start to see other parts of the scene kind of glow. You probably see it most on the lighting that I already had here in the scene. Some of that's kind of glowing. But for most kind of applications, you'll probably just have the threshold here down as 1. This scene is set up to be somewhat realistic, so these the 1 on the threshold and the intensity is normally good enough for most kind of use cases. And then the third post-process effect it adds is vignettes, which is basically it darkens the corners of the screen. Kind of similar to how your own vision works. Your vision isn't just like a rectangle that's like perfectly bright everywhere. You'll get the shadow from like the side of your eyeball, your eye socket basically. Passing kind of dark bits on the edge. And it kind of mimics how that looks. So on my vignette, if I just raise the intensity a lot, then it'll kind of look dark from the outside. It makes the scene look a tiny bit more realistic. Those are the 3 post-processing filters that you need to see your scene automatically. There are more you can add, so we can add overrides here, and there's a bunch more, but I won't go into all of them because we'll be here forever. So yeah, that's my glowing object. Are there any kind of more questions to do with the emission and the intensity of that? Yep, good. If I select my object like before, I can overwrite this color as well, so I can take my intensity and I can raise it if I want. So if I raise this to something like 5, the object glows more. So the same as the base color property, we can just modify the intensity of this color, or the base, kind of the hue of this color as well. So I can make the glowing blue instead. That's all fantastic. that's all the kind of the basics, but so far we're kind of just kind of shifting around colors. And there are some more interesting things you can do with Shader Graph. So I can't remember how many of you were kind of here for the lightning talk I did a few weeks ago when we did lightning talks. But I did a very short kind of demonstration of Shader Graph. But I guess I will do the same thing I did then, since kind of none of you were here. I'm going to make a kind of a hologram effect, and it's going to pull together some of the bits we've learned already and see a lot of new things as well. So for the hologram, I kind of want an object to kind of have sort of scan lines that travel down the object. So I want it to kind of be partially transparent, I want it to be emissive, and I want it to kind of have this scrolling. So one of the things when it comes to shaders, and actually something that I kind of like see people say a lot, is that they kind of understand how to actually do the technical bit of making shaders, but they don't really, they're not as good at like looking at an effect that already exists and working out how to make the shader from scratch. So if I were just visualizing a hologram effect for now, if I just think about the components that I'll actually need to make that shader, like I just mentioned, we'd want to miss emissive lighting because it's a hologram, we want it to kind of glow. We want parts of it to be transparent, so we're going to use a transparent shader rather than the opaque ones that we've been using so far. But we also might want the scan lines to kind of scroll over time, so we'll want to use time in our shader, and we can do that. And we'll also want some way of actually making the scan lines appear. So there's loads of ways you could do that. Either we could import a texture that has kind of like some bright white lines, but then some dark bits and kind of intermediate parts that will kind of control where the scan line appears, but we can do that just by generating a pattern inside Shader Graph itself. So there's multiple different kind of thought processes we could go with when trying to make a shader like this. If you're kind of interested in making more shaders after this, I kind of like encourage you to look at an effect that already exists in the game and think, oh, okay, what kind of textures are they using? What shapes are those kind of textures? Kind of what's happening to them? And by breaking down exactly what the effect is doing, it makes it a lot easier to think about what nodes you'll be using in Shader Graph. And there's a lot of nodes. You won't know all of them from the start, and you don't need to know what all of them do. But there are things that you will pick up kind of as time goes on. So the more that you use Shader Graph, you'll pick up kind of what's possible. Similar to kind of Unity in general, as you code more in it, you'll figure out what more kind of functions are available, and that kind of stuff. So there's stuff you pick up as you go on. But I've been using Shader Graph for a while, so I already know what nodes I want to use. So if I go back into the graph, I'll just kind of bring my window out again and maximize it. I will probably actually delete all of this, and then we'll just start from scratch. Yeah. So we're starting from a lit shader graph. Like I mentioned, my hologram will want to have some kind of transparent bits on it. So the first thing I'll do, in my graph settings, I will go to the surface option, and I'm going to select transparent. Now it's going to add one last option down at the bottom called alpha. Like I mentioned, alpha just means transparency. So if alpha is 1, then my object is opaque. If alpha is 0, then it will be fully transparent. And anything in between is going to be a mix of those. So 0.5 is going to be semi-transparent, and so on. So we have one more option to play with than before. So probably the most important part of the hologram effect is going to be actually determining where the scan lines will appear. So multiple ways of doing this. Basically, I'm going to want to get the kind of the position of each pixel in space, in real physical space, and I want to drag this pattern down over time. So the first thing I want is, what is the position of the object? And there's a position node for that. So if I right click, go to create node position, and we want the one called position, not the one called screen position, because that's different. It brings up this kind of funny looking node here, and it has one option called space on it. There are multiple different spaces that objects can exist in, and it's kind of a little bit beyond the scope of this whole session, but very briefly, there's a bunch of options here. Object space is basically every vertex of the object is relative to the object's own pivot point. So if you were to model an object in Blender or Maya or any kind of modeling program, your vertices of the object are relative to like a pivot point of the object rather than a place in the world. View space is relative to the camera's position. So say from my perspective, like the vertex of the corner of that table is like it's a vector from like the middle of my view to that vertex. The world space is kind of what you're probably most familiar with in Unity. So if we were to modify, so if I select the sphere, and if I modify the position here, that's the world space. So the world space of this vertex is, it's like this amount plus whatever offset is from the center of this object to that vertex. And that sounds like basically what we would want. So we're actually going to use world space, and then just to kind of wrap up everything here. There's also tangent space, which is relative to, if I remember correctly, it's relative to each vertex itself, which is a little bit kind of weird in this context, but tangent space is if I select a vertex, then we kind of define things relative to kind of what its normal vector is. I kind of mentioned the normal vector very briefly before, but you won't use that very often. We want world space basically. So the world space is going to be, this vertex and where it is in the entire world. And we're basically going to use the Z component, the Y component of that. We want the component of that kind of facing upwards. And we're going to say, how high up is this? And we're going to explore that over time. So, like I mentioned before, there was a split node because this position is a vector 3. It's got an X, Y, and Z component. Where they are the X position, Y position, and Z position in space. We only want the Y position, that's the only one we're interested in. So I'm going to use a split node. And the kind of sort of maybe confusing thing is that it's actually giving us 4 outputs here. Because we input a vector 3, it has 4 different outputs. The A output is one that's going to be kind of like, it's going to use a default value. That's kind of invented for us. If I remember right, it's either 0 or 1, and I can't remember which one of those it is. It might be 0, but we won't need that anymore. The one that we're going to use is the G output. That's the second annoying thing here, is that even though we're using positions, which we use X, Y, and Z to represent the positions, they're still giving us R, G, and B as our outputs. And that's because in Unity, colors represented by RGB and positions represented by X or Z are the same thing. So they're just all vectors. And vectors are all like the same type in shaders. There's no distinction between this is a color and this is a position vector. They are the same thing. So every time you see RGB or RGBA, it corresponds, it's the same thing as saying XYZ or XYZW. So here we want the Y position of this kind of object. We use the G output from this split node. So I think, actually I can preview this here. One of the nice things about Shader Graph is that you see kind of visually what everything looks like at every step. And there's an extra node to do that. It's a preview node. So I'm actually just going to kind of output that there from the G output of split. And this is just a kind of a sanity check. I wanted to check if I got the right thing. And I do, because kind of another thing to explain here is that this is only a one component vector, so it's only a vector 1, which is the same as just a number. What Unity will do then is if you preview it anywhere, it's not converted to grayscale, so 0 is black, 1 is white. This is giving me what I want. So kind of want this bit in the middle of this sphere. That's 0, black. The world position of that is 0. And as you go up, the Y position of this kind of like the bit at the top is 1, so that's fully white. And then if we go below 0, that's like minus 1, but it's just kind of flipped to black. This is what I wanted. I wanted kind of a value that goes up, down based on its Y position. So now we've got the Y position, we want some way to turn that into lines. And there's probably a few ways you can do this. You could either I actually think of some few ways to do this. So the first one, the one I probably will use is the sine function. So max sine is a board actually. Before I break everything here, I bought my whiteboard pens today. I hope they work. So you'll remember your friend sine. I hope this is kind of big. I can't remember if sine starts some origin or not. It does, isn't it? Yeah. So sine. Sine will go like this. Similarly, we could use a cosine function, which is just that shifted by pi over 2. I can't remember what I asked today. So that's going to be great. If we kind of put this position into a sine function, it's going to kind of oscillate over time. So actually, I'll show you that. Let's say sine. It's actually not going to look any different currently because it's only bounded from 0 to minus 1. So actually, there's going to be one cycle of sine. So what we're actually going to have to do is multiply this by some kind of amount beforehand, and I'm just going to kind of hard code this on this node rather than worrying about another property and stuff. For now, I'm going to give it like a value of 100 on the other input, and kind of put that into the sine node, and yeah, here's our fan lines. So that's kind of basically what we wanted. So I can't see, but we've got the multiply here. The other number I put into the B input into multiply is 100. And then I've output that into the sine node, and it's given us this kind of the scan line kind of pattern. I kind of just move all these nodes to the side. One kind of pitfall to kind of mention ahead of time is that obviously since we're using a sine node, the outputs are going to move between this is -1 and this is -1. So when we get to multiplying the colors together, sometimes this can look a little bit weird if you have negatives. So one thing I'm going to do before we move on from the sine node here is I'm going to clamp the value between 0 and 1. So if I don't do this, then the output here is -1, 1. That gets a little weird with color sometimes. So clamping is going to say if anything is below 0, I want to clamp it to 0. And then the rest of the values are fine. Anything above 1, I want to clamp it to 1, but nothing's above 1 anyway. And there's two ways to do that. Either we can use the clamp node. So the clamp node, we have an in option, and then we have a min and max option. And that's actually as we want it currently. The min is 0 and the max is 1. But clamping between 0 and 1 is such a common operation in shaders that they have a node to just do that for us. So we don't have to worry about a clamp and then manually having 0 and 1, although it's actually there by default. The other way to do this is another node called saturate. And saturate is a kind of, again, it's a technical term, kind of a shadery term. Saturate, not to be confused with the saturation of a color, which is another kind of thing. Saturate is equivalent to a clamp that clamps between 0 and 1. So that's the one we want. So now we can be sure that we have no negative values from the output. That's kind of be useful because sometimes it breaks. So now we can actually just output there to our base color, and let's kind of rotate that a bit. That's starting to look like what we want it to look like. The other thing, of course, that we wanted kind of some transparency. That's perfect because we have values from 0 to 1 here. So I'll actually just output this to alpha as well. I'm going to take a little while to... it's hard to see on this preview on the projector, but on your own screens, the moment that you output this to the alpha channel, which is how opaque your object is, you'll notice that the background here, these in-betweeny bits change from being black to being kind of grey because they're being mixed with the background of the actual preview window. So these are actually transparent now. If I, for now, just save my asset and then kind of have a look at what this looks like in the scene view, you'll see it's sort of starting to look like what we want it to look like. There's no scrolling yet, and there's no emission, so we will add those. Back in the shader F, kind of maximize it again. So round about here, when we kind of we got the Y position, this is where we're going to want to add a time offset. So that's quite easy to do as well. Just trying to think if this will throw up any problems. I don't think it will. Before we output to the sign, we're going to create another node, and this one is called time. And time gives us a bunch of different values as outputs. Time is just outputs, you don't input anything to it. Let's go for what they all are. The first one is just for time, and that is the time in seconds since the level started. So that just counts up forever at a rate of 1 second per second. There is the sign time, and that is going to be equivalent to taking the time output and putting it into a sine node. Same with cosine time, equivalent to putting the time output into a cosine node. We don't want those because we want to add this to something before putting it into a sine node. But there is also delta time, and delta time is the amount of time that elapsed between this rendered frame and the last one. So we saw delta time before in scripting, but we use delta time to make our kind of our movement independent of the frame rate of the game. You might have effects that also have a similar kind of requirement in your shaders, although to be honest, I don't think I've ever needed to use delta time in the shader, but it's there, I'm not going to need it. There's also smooth delta. And I can't remember exactly how smooth delta works, but smooth delta is like delta time, but it's smoothed out over a certain number of frames. So sometimes you'll see if you kind of move things with delta time, it can be a little bit jittery. With smooth delta time, it tries to average out the kind of amount. How do I put it? Kind of if you have lag spikes in the game. So if you have one frame that takes way more time to render than all the other frames around it, the smooth delta is going to kind of average that out, so you don't have this outlier. So you don't have one delta time that's like really high and one delta time that's really low. The smooth delta just kind of averages them out over time. But again, I've never used smooth delta in a shader. Probably won't need to. But for now, we're only interested in time. Just the time, the regular time output in seconds since the thing started. Hello. I've kind of been paired at this time. That's you to finally show up to a workshop. Well,
yes, I've shown up, I'm not staying.
You've shown up, congratulations. So I'm going to take the time option here, and I'm just going to add that. So there's an add node, similar to the multiply. It doesn't matter kind of which order you do them in. So I'm going to go add, and I'm going to put it in the A input. Kind of one thing you'll notice here is that a lot of these nodes are kind of really big and chunky and are taking up a lot of the screen. One way we can kind of fix this and kind of make our graph a little bit easier to read is if I select the add node, you'll see on the kind of the preview bit below it, there's this little up arrow. If I click that, it just kind of collapses the node. So I will also do that with the multiply. Makes it a lot easier to kind of follow what's going on the graph. So I'm going to take the output of the multiply and put that into the add, and that's going to add our Y position that we had before. It's going to add the time offset to it. And then I'm going to output the add to the sign. So that's moving very, very slowly, I promise. You'll be able to see it slightly better on your own screen, but in the main preview now, it should be moving very slowly. We could, if we want to kind of speed this up. Oh, and add another property to control that. So in the kind of the properties window, if I click the little add button and I click float, I'm going to call this speed. So speed. And then similar to the other properties, we have these kind of default kind of values that we can change. I'm going to change the default to something like 5. something a little bit faster. And then, like the other properties, I can kind of drag it. If I remove the time up there, I can drag the speed property onto the graph. And I'm going to do a similar thing I did before. I'm going to multiply that with the time before putting it into the app mode. A little bit smaller, put that into the add, and now it should be kind of, you can tell a lot easier that it's actually kind of scrolling down over time. So technically what that's doing is taking the time, it's multiplying it by the speed property, the 5 that I just put in. But the kind of the end effect here is it's just making the time scroll faster. So that's kind of what we wanted. So yep, we have the scanlines are working great. Scanlines are kind of scrolling over time now. The last thing that I want to think about is the emission color. So when I first kind of generated this pattern, I just outputted it to base color. I'm going to actually undo that. So just to kind of redo what I did there, if you have one of these connections here, one of these lines, you can delete it just by right-clicking the line itself, and then there's a delete key. Or a delete button, a delete option. Now it's red because my default and base color is red. I'm actually going to use the base color property we made before. I'm going to drag that back on, and I'm going to output that to base color. What I want to do instead is I want to use emission for the scan lines. Give me a second there. See, I want to use an emissive color for the scan lines rather than just being a base color. I want them to glow. So it's going to be similar to how we did before. It's just going to be multiplying the scanline texture that we have here, the scanline pattern that we have here, by the emissive color that we had before. So all I'll do is I'll take the emission color that we had made before, and I'll multiply that together with the results of this saturate node. Let me move this out of the way a bit. And then I can output that to emission. And it's going to give me the preview's not going to look emissive because, like I mentioned before, you need, well, it looks emissive, it doesn't look like it's glowing. And that's like before I said I needed like a blue for process, but the preview window doesn't have that. It just kind of looks pink for now because that was the default color of my emission color. But if I save this now, I actually think you need to click the save asset button. I don't think Control S actually saves it properly. So I always, out of habit, click the save asset button in the top left corner. And then if I minimize my window and box that again, I'll look here. You can kind of see it's glowing. And the only reason it's glowing that color is because I actually changed what the color was before. So if I make the base color of white, I can change the. I can actually change this kind of. Hopefully look a little bit more blue, but you can kind of see how the glowing is changing color when I change the hue of the emission. So yeah, it's just a very easy way of making scan lines kind of appear using Shader F. If you notice that any animated textures or any animated materials that you have kind of like stop working like that, there is actually a little drop down. It's kind of hard to see. It's the one that looks like a load of squares laid on top of each other with a little sparkle next to it. Right on the top here. On the drop down, if you click the always refresh option, it's just going to force Unity to always redraw the scene view every single frame like you'd see in a game. So it's going to animate the texture, animate the material properly. I think as one last thing for this hologram material, this hologram shader, is I probably want to have an option for how kind of thin the lines are. Let's very quickly add that. So we'll go test graph. If I maximize, and And add a property again, and this is going to be a number, so I'll pick float. And if I call this scanline density or something similar, I can make its default value about 100, which is what I used in the graph. Let's make that 100. And then here on this multiplier, rather than hard coding the value to be 100, I'll just drag that on here. It's generally a good idea if it's something you think that someone else is going to want to change later on to make it a property. A lot of, certainly when I started to use shader graph, and some kind of newcomers to shader graph will kind of hard code the values inside the shader graph itself, and it makes it a little bit harder as an outsider, someone who's just kind of, if I've been given this graph and I'm making materials with it, it's going to be harder to change some of the kind of the way that the graph, the way that the shader works. It's nice to have those properties, just so it's easier to kind of change externally. So you won't want to make everything a property, because then you'll have to sort of drag down to list of properties and stuff that are very simple or very obvious things you do kind of in the graph, but I hope it kind of makes sense. This is something I'd want as a property, because it's something I might want my scanline to be denser. So yet again, I'll save. Minimize my window. And then now on my material, on the scanline density, I can bump this up to 500. And now my scanlines are really close together. So it was kind of vaguely hologrammy. It's not the best hologram effect in the world, but that was quite easy to put it, quite quick to put together. If you wanted to do that in a code shader, so if you wanted to write a code-based shader to do that, it's a lot more difficult. Even though I use code shaders a lot, I would find that more difficult. Yeah, so that was kind of your introduction to shader. Are there any other questions or anything you want me to kind of show? I like it. Right, I'm happy to end the session there then, I guess. That's kind of the basics. Thank you for listening.